In this video, I'm going to go over what are asymptotes of a graph. And here we're talking about specifically the graph of a rational function. So let's just define it as f of x will equal to, and then the numerator, I'll use n for numerator, will be a polynomial. The denominator, I'll define it by d, is a polynomial. And of course we want the denominator not to equal to 0. So d of x cannot be 0. Okay. So this could be something as simple. The numerator could be something like 1 over, and the denominator could be x. Okay. So an asymptote basically is a line that the graph approaches, and in general it doesn't touch in general. Okay, so you could have basically for a rational function, you can have vertical asymptotes, you can have horizontal, you can have a horizontal asymptote, or you could have a slanted asymptote. So in this particular case, let's just look at, okay, so here we have the coordinate system, the y-axis, the x-axis. So we could have a graph that looks something like this. Okay. So I'm drawing a graph that approaches the y-axis from the right, going up, getting closer and closer, but not touching, and approaches it from the left. Okay, coming down this way, getting closer and closer, but not touching. And then we have the graph coming down here, approaching the x-axis, closer and closer, but not touching, and then over here on this side. Okay, so in this case, I would say that the y-axis represents a vertical asymptote. The x-axis represents a horizontal asymptote. So you could have vertical asymptotes, you could have horizontal asymptotes, you can even have slanted asymptotes. So in general, again, an asymptote is a line that the graph approaches, generally does not touch. Now, the graph could touch a horizontal asymptote at a point and still be considered a horizontal asymptote. The graph will never cross a vertical asymptote because the vertical asymptotes come from values where the function is not defined. So in other words, if there's a number that makes the denominator 0, if there's a value that makes the denominator 0 but not the numerator, then you're going to generate, the graph will have a vertical asymptote. So if you look at this right here, if I call this y, or f of x, that's the polynomial function. And actually it turns out that what I just drew here represents the graph of this rational function. Okay. Notice the denominator is 0 when x is equal to 0, but the numerator is not. Okay, so any number that makes the denominator 0, but not the numerator, basically is going to generate a vertical asymptote. So the graph of x equals 0 is the vertical line that passes through the origin. So actually in this case, it's the y-axis. Now, also turns out that if you have a rational function, if the degree of the numerator is less than the degree of the denominator. In this case, because I have a constant in the numerator, the degree is 0. Okay, in the denominator I have x to the first, so the degree is 1. So 0 is less than 1. So whenever the degree of the numerator is less than the degree of the denominator, you're going to have a horizontal asymptote, which will be the line y equals 0, which of course corresponds to your x-axis. Okay. Now, if the degree of the numerator is larger than the degree of the denominator, then you have no horizontal asymptote. But you could have a slanted asymptote. if the degrees differ just by 1. In other words, if the degree of the numerator is larger than the degree of the denominator by 1. So this is degree 2, say this is degree 1, or 3 and 2. So the graph will never cross a vertical asymptote, but it can cross a horizontal. So in other words, you could have, say, something like this, where the graph goes like this, and then like this, and then as x goes to infinity, the graph gets closer and closer to the x-axis, but never touches it over here, or the same thing over here. But notice it crossed at the point 0, 0. So that's why I say the graph, in some cases, could cross a horizontal asymptote. And by definition, we would still have a horizontal asymptote. Now it's possible, like I said, to have a slanted asymptote. Okay, so you could have something that looks like this, or maybe the graph could go like this, something like this, or you could have something like this. So in this case, the graph approaches the y-axis as I go up here, down here, and then it also approaches this line right here. Okay. So this would be a slant, also called an oblique asymptote. Okay, so let's clear this. So one example that I have here, if I look at this polynomial right here, this rational function, I should say. Notice that, just to show you here, when x is equal to 0, I have 0 divided by -9, so I get 0. So I know the graph passes through the origin, 0, 0. Now the denominator is 0 when x equal to 3. And when x is equal to -3. Now since the numerator is not 0 at those values, then x equal 3, which say would correspond. I go say 3 units, let's say this is 3 units from the origin, and over here we have 3 units in the negative direction, -3. So x equal to 3 and x equal to -3 would be your vertical asymptotes. Okay. Notice the degree of the numerator is 1. The degree of the denominator is 2. So based on what I just said earlier, then I should have a horizontal asymptote at y equal to 0, which of course is your x-axis. So this is your x-axis and your y-axis. So if I were to plot some points or use some basic algebra, we would see that the graph actually goes something like this. So approaches the vertical asymptote x equals 3, approaches the horizontal, then at this point right here it comes down like this. So notice the x-axis is a horizontal asymptote. This goes up this way. And over here it comes down this way. So this is another example where the graph crosses the horizontal right here at 0, 0. But because this x goes to infinity, it doesn't cross over here anymore. Okay? And of course we know that for a fact. We know that it doesn't cross the x-axis over here because what? We only have one x-intercept. Okay? And of course the y-intercept is the same. 0, 0 is an x-intercept and a y-intercept. So this is what we have. So again, in general, for For a rational function, you can have vertical asymptotes, you can have horizontal asymptotes, you can have a slanted asymptote. If you have a slanted asymptote, in general, you're not going to have a horizontal. Okay? Or if you have horizontal, you're not going to have a slanted or oblique asymptote. Okay? So that concludes this video. Hope it was informative. We'll see you next time. Thanks for watching.